Namaste. This is Surabhi, a master teacher of chemistry at Vedantu. Welcome to this session, everyone, where we will be studying periodic classification of elements in one shot. So be ready. I mean, it's really better if you have your water bottle with you and if you some snacks and do not fall asleep. Okay, so before that, here is something which I would tell you or I would want you to know about. So we have a pro subscription course where you can just go to the link given in the description or in the pinned comment or go to vdnt.in/ytpro and take up the pro subscription. So there will be, of course, you will be saving like around 14 to 15% if you are going for the 3-month or 6-month subscription. But I don't think 6 months is necessary because we have around 4 months left. So 3 months enough. And if you use the coupon code SURPR, you will be getting additional discount. Why should you take it? Because I am getting to learn free on YouTube. But there are certain features which is not available on YouTube, but which we have on Vedantu platform, like in-class doubt solving, which is very, very important. I guess that is the major concern of every student, right? And maybe the notes and the assignments will be shared with you. So this will help you to practice and master a topic or a chapter or a subject. And we have different kinds of courses like micro course, crash courses. So once you have taken the pro subscription, whatever the new courses which we are coming up with will be absolutely free of cost fee. That is it. Yes, the coupon code is SURPRO and less is more, because greater the number of sessions you will take, lower is the price you have to pay. Yeah. So what is the learning objective? So it's the whole chapter. Let's get started. So at present we know 118 elements, yes, absolutely, but among them like only 94 are naturally occurring and the rest are man-made or synthesized one. The thing is, if you look at whatever we are studying now, right, like we have other chapters as well, like acids, bases and salts, metals and non-metals. So we always compare, see, this is a metal, this is a non-metal, so chemical properties of metals and non-metals, because we know the property and it is very much easy for you to look at the element and talk about its properties and its nature, because we have a very well arranged periodic table. But how did we end up with that? So was it completely arranged it in a single day? No. So there has been a whole history behind the periodic classification. So that is what we will be discussing in this chapter. So one thing, the scientists, or to be specific, the chemists, they realized it that the periodic classification is very, very important for the, to make it easy to study the elements or their properties, but they didn't know what should be the fundamental property. So there should be a criteria, right? So for example, in the prayer hall, you will stand according to the height, so like that there should be a criteria, so using which they can actually arrange the elements which were known there. So why the classification is required is very, very important, right? So why classification is needed? The thing is, as you all know, we prefer going to supermarket than the open market, or maybe the closet. It is very easy to find a pair of t-shirts, yeah, kuch bhi, if it is very well arranged, right? The same reason, this is exactly why the classification is very, very important. You can find the element easily, you can actually compare the properties, and see, now I have group 1, so all the elements in the group 1 have similar properties, right? So study of elements have become easier because of the classification. That is the reason classification is very, very, very important. So how did it start? First, they actually took almost 30 elements were known, so they just took it and they just put into metals and non-metals. That was the only classification. Bichara metalloids were like, where am I supposed to go? So in the year 1817, so Johann Wolfgang Dobereiner, so he was a German chemist. What he did was, so he identified some groups at a set of 3 elements, and when he arranged the elements according to the increasing order, he figured out that so the average of the first and third element atomic mass will give you the atomic mass of the second element, and he called them as triads. Okay, so for example, if you take lithium, sodium, potassium, that's a triad, or calcium, strontium, barium, that's a triad, chlorine, bromine, iodine. So we have three triads. But here, if you look at it, lithium atomic mass is almost 7, 6.9, and potassium is 39.0. And also, if you take the average, it will come somewhere around 23. That is, the average atomic mass of lithium and potassium will be same as that of the atomic mass of the second element, that is sodium. You can actually see here, this is the table: lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine. Okay, so this is about the Dobereiner's triad. This was the first classification where actually he tried to compare the property, and where someone tried to arrange the elements according to the increasing atomic mass. But the drawback was he could identify only three triads, and there were other two triads which were not at all chemically similar. So that is the reason we are not following it. And then came John Newland, so English scientist, in the year 1866. So what he did was he arranged the then known elements according to the increasing atomic masses, and what he observed was every eighth element had the same properties as that of the first one. So that exactly is the reason it is called as law of octaves. So even in the the music also, these are the musical notes which we use, right? Sa re ga ma pa da ni. Then the next higher range pay, it will be sa again. So he found that every eighth element has properties similar to that of the first one. So that is the reason he has called this law, or the arrangement of elements, as law of octaves. So if the chemical elements are arranged according to increasing atomic weight or mass, those with similar physical and chemical properties occur after each interval of 7 elements. So there you can actually see the periodicity. So there is this repetition of the properties at the regular interval. So this is the major achievement, you can call it as the achievement of Newland's law of octaves, because this was the first one who brought out that there is some kind of systematic relationship between the atomic mass and the properties. So you can see here, so lithium, this, if I consider this as a first element, then 2, 3, 4, 5, 6, 7. So 8th element, that is sodium. So lithium and sodium have similar properties, or beryllium, magnesium, boron, aluminium. Okay, but coming to the limitations of the Newland's law of octaves, of course, there are a lot of limitations. Firstly, it is applicable only to the lighter elements, that is up to calcium, and after that, no. And what he did was he tried to fit all the known elements into his periodic table, or into his arrangement, to make sure that he will have all the elements in his table. But then while doing so, he actually put the dissimilar elements together that were in the same group, and the elements with similar properties were placed far from each other. And he even tried to put cobalt and nickel in the same slot. You must have seen, right? So it is in the same slot. So that is again the another limitation of Newland law of octave. And one more is, so after the discovery of noble gases, he could not accommodate the noble gases, or noble gases didn't fit into this arrangement which was suggested by the Newland's law of octaves. But of course there are achievements of Newland's law of octaves too. So that is, one is the Newland's law of octaves worked very well with the lighter elements, and then, as I told you, so he showed that there is some kind of systematic relationship between the way you are arranging elements and their properties, and the repetition of the property. Next is super important and a major contributor to the periodic classification, that is Mendeleev's. So if you have attended my sessions, then I really like this guy. I mean, the way he actually brought out the periodic classification is really, really, really nice. What he did was, if I have to tell you in a form of a story, so he just wrote down the atomic symbol and the properties of each element in the form of cards. Okay, so how we get this A for apple card with the image, right, with the picture of an apple and all that, in the same way. So he just almost, like, then 63 elements were known, he just wrote it out, And then he started arranging the elements according to the similarity in their properties. That is, physical property is atomic mass, and chemical property, which he considered was the formula of the oxides and hydrides. So those, what kind of hydride or oxide is that element forming? So those elements with similar hydride and oxide ka formula, they fell into the same group. And one more thing he observed was, so when you arrange the elements according to the increasing order of their atomic masses, so there were the repetition in the properties, that is, he could observe the periodicity, and that's how he gave us the modern periodic law. So this is something I've already explained. It's always nice to hear in the form of a story, right? So what is the Mendeleev's periodic law? The properties of elements are the periodic function of their atomic masses. So what does it mean? What is a periodic function? See, the properties of elements are repeating at the regular interval. Okay? That is because you have arranged the elements according to the increasing atomic mass. If you have arranged the elements in a random order, you wouldn't have seen that repetition in the property. So that is what this periodic law means. So Mendeleev's periodic table, it contains the vertical columns, which are known as groups, and the horizontal rows called periods. So you can find 8 groups and 7 periods in his periodic table. Now coming to the achievements of Mendeleev's periodic table. So of course he did a lot, he has contributed a lot. Let me repeat it again, because he left gaps in his periodic table for the elements which weren't even discovered yet, but he knew that those elements should take that place, and he even tried to predict the properties of those elements based on the position of those elements, the gaps. And his prediction were almost right, very close to the actual numbers, that is density, atomic mass and all that. And there is this thing that cobalt and nickel, so this we study under limitation as well, but if you want to consider this as a achievement, even though he knew that there is wrong order of atomic mass, he just interchanged their position to make sure that they're similar, the properties could be the elements with similar properties could be placed together. Mendeleev's left some gaps, yes, and his periodic table could accommodate the noble gas without actually disturbing the already prepared Mendeleev's periodic table. So that is also an achievement or a very good thing about the Mendeleev's periodic table. So eka boron, eka aluminium, eka silicon. So these 3 names are very, very important. So I want you to remember them. Okay, they will ask you. So which are the 2 elements or Mendeleev tried to predict the properties or the position of these elements? What are those? Those kind of questions can be asked based on this topic. So it is very, very important. So please pay attention to that part. Okay. So noble gases like helium, neon and argon, so they have been mentioned in many contexts before this, but he could even accommodate them in his periodic table without actually disturbing the previously prepared one. Now coming to the limitation, sadly, even though it almost looks like a perfect periodic table, there are few limitations. Like he could not explain the position, so he could not give a fixed or proper position to hydrogen, and he could not explain the position of isotopes, which were, we came to know about isotopes like very much later after this Mendeleev's periodic table, but he could not explain the position of isotopes and wrong order of the atomic masses at few places, which you can observe in the periodic table, but he could not explain why there is wrong order. So these are the limitations of the Mendeleev's periodic table. Now coming to the modern periodic table. So in 1913, in the year Henry Moseley, he said that no. So the previous periodic tables or the arrangement of elements, if you observe, they have taken the atomic mass as the fundamental property. No, but atomic number is a more fundamental property than the atomic mass. So when you arrange the elements according to the increasing order of atomic number, not the atomic mass, maybe then you will get a better periodic classification of elements. And he even gave us the modern periodic law. So Mendeleev's periodic law is basically you just have to change one word, that's it. Their atomic mass, here it will be atomic number. Okay? Okay. Now coming to the statement, which is again important. So I have seen students getting confused between the Mendeleev's periodic law and the modern periodic law. See, Mendeleev's periodic table mein he focused on atomic mass, and modern periodic law it is atomic number. Now what exactly is atomic number? So obviously it is atomic number is the number of protons present in an atom, right? It tells you about the total number of protons in it, and it is something which does not change. So for a given element, it can have only one atomic number. For a carbon, of course, it has more than one mass number. Atomic mass is different, that is we have isotopes, but the atomic number is same for everything, right? Isobars, isotones or isotopes, you talk about anything, we have never said there will be change in the proton number. If there is change in the proton number, obviously you are changing the element itself. So this is exactly the reason why this is a more of a fundamental property than the atomic mass. So this number increases by 1 in going from one element to the next element, and Niels Bohr, he was the one who gave us the modern periodic table. Please don't get confused. Modern periodic law, Henry Moseley, and the Niels Bohr, he gave us the modern periodic table. So when you arrange the elements according to the increasing order of their atomic number, so that is when you end up getting the modern periodic table, and this is how it looks. Ta-da! But the thing is, you might be wondering, why does this has a peculiar shape? Like, why couldn't we just like a rectangle and all that? But if you once we learn about the groups and the periods, so S block, P block, and all that. So here it's basically the first shell is getting filled, and here it is the second shell, third, fourth, and it just goes on. That exactly is the reason why it does not have a rectangular shape, but this one. But this actually makes the study of the elements easier, even though its shape is not. It's nice, right? I like it. So what is the advantage over the atomic mass? So firstly, prediction of properties of the elements could be made with more precision, because the properties is basically it is dependent on the valence electrons. Don't you think so? Whenever we talk about the property, this is more acidic, this is basic, this forms basic oxides and all that. So it's all about everything will come to the valence electrons. So if you want to talk about a chemical reactivity or a property of an element, I guess it's all about the valence electron. So obviously the number of valence electron and the number of electrons is equal to number of protons. So that is where the prediction of properties will be more precise and accurate when we consider atomic number as the fundamental property. And when we did this, when you arrange the elements according to increasing atomic number, so you can actually remove the anomalies of the Mendeleev's periodic table, like the hydrogen position. So now we all know it has its atomic number is 1. Of course, you will study about the hydrogen position even under limitation as well, but they tried to actually, so according to the atomic number, so we have just placed it at the top of the modern periodic table. And cobalt and nickel, so it was once you place them according to their atomic number, then obviously that anomaly could also be removed. And isotopes, see, isotopes, they have same atomic number but different atomic masses. Now this periodic table or the classification is based on atomic number, so every element gets only one position. Okay. So is it possible to have an element with atomic number 1.5 placed between hydrogen and helium? Of course no, right? What do you think? Let me know in the comment section. Now coming to the total number of groups and the periods, so the salient features of the modern periodic table, we have 18 vertical columns which are called as groups and 7 horizontal rows which are called as periods. Okay, so they used to use the Roman number, but according to IUPAC, so we are using the English number, that is 1, 2, 3, 4, 5, 6 to 18. And the elements in a group contain the same number of valence electron. If I'm talking about the group 1, then obviously it contains 1 valence electron. Group 2 will contain 2, and group 13 it contains 3. Group 14 will contain 4 valence electron. That is how it is. And the elements with the same number of valence electron, they are present in the same group. So importance of groups, of course, as it has same number of valence electron, their valency will be same, and the chemical properties, as I've told you earlier, it depends on the number of valence electrons. So predicting the chemical properties will be very easier on the, if if it is based on the electronic configuration. And the number of shells as you go down the group, it increases. So elements have same number of valence electron, but they contain different number of shells. So their physical properties will be, of course, there will be gradually, there will be gradual change when you go down the group, but their chemical properties will be almost same. Now coming to the periods, the number of valence shell electrons increase by 1 unit. So here if you have, it's white, no, let me just change the color. Yes. So here if you have you have sodium, magnesium. So sodium is 281 and magnesium is 282. So for a given period, in a given period, the electrons will be added to the same shell. Okay. So there you will just see there will be addition of electron as you go from left to right. That is it. So the atoms with same number of shells will be present in a period, and the atoms or the elements with same number of valence electron are placed in a same group. Number of elements in a period, so it is given by the formula 2n square, right? So the maximum number of electrons that can be accommodated in a given shell. So obviously the first period that contains 2 electrons, and maximum number of electrons is 2, so you will find 2 elements there. And next, coming to the second and third period, it contains 8 elements, and third and fourth, or fourth and fifth, it contains 18 elements, and sixth and seventh, it contains 32 elements. Okay, so first 2 elements, second and third 8 elements, fourth and fifth 18 elements, and sixth and seventh, it contains 32 elements. So that is 6th and 7th, the lanthanides and actinides are the continuation of the 6th and 7th period. Okay, so in total it will have 32 elements. And now coming to the groups, the first group, it is called as alkali metals because they form strong alkalis. So you will find lithium, sodium, potassium, rubidium, cesium, francium in that. And the second group is called as alkaline earth metals. So even though it forms the alkalis, that is water soluble bases, it will be thoda sa weaker than the first group bases. So beryllium, magnesium, calcium. And group 13 is called as boron family. Group 14 is called as carbon family. Group 15 is the nitrogen family. Group 16 is oxygen or also alkogens. Group 17 is halogens. Group 18 is noble gases. So you might be wondering, why don't we talk about the 3 to 4, right? So they are called as transition elements. So very soon in the foundation series, so we will be starting with D block elements. If you are very curious about why do we use it, why do we use these elements, like chromium, manganese as the oxidizing agent or as the catalyst, or why are they colored, then you will get to know the reason very soon. Okay, so group 13 to 18 is P block. So basically 3rd to 12 is D block, and first and second group is the S block. And the last lanthanides and actinides, they are called as F block. So boron family, carbon family, nitrogen family, oxygen family, halogens, and the noble gases. So you should know why they are noble gases are called as, 18th group elements are called as noble gases or inert gases. Okay, so this is S block. Okay, this is D, this is P, and this is F block. Don't use the capital one, it is small. Okay, you know about the subshells, right? SPDF, the same it is. Okay, because the electrons will are added to the S subshell, yeah, D subshell, yeah, P subshell, yeah, F subshell. That's how it is. Okay, cool. So you better be answering when you're watching the video. Don't just sit. So merits of the modern periodic table classification is based on the atomic number, which is a more fundamental property of an element that is a major advantage of the modern periodic table over the Mendeleev's periodic table. The reason for placing isotopes at one place is justified because it has only one atomic number, right? Because the classification is based on atomic number. And then coming to the periodicity, so even though Mendeleev, he said that there is periodicity, there is repetition of properties, he could not explain why. Because how are the atomic masses will lead to the periodicity? But this modern periodic table, it explains that why there is periodicity. It is because of the similarity in the electronic configuration. The number of valence electron is same for the elements present in the same group. That is the reason you are finding the properties are being repeated at regular interval. And the lanthanides and actinides are placed separately at the bottom of the periodic table. So this point can be a merit as well as a demerit. So first is the position of hydrogen is still not fixed. We really hope 2021 mein ho jayega. Let's see. And the lanthanides and actinides, why are they not placed in the same body? So if they were placed, this is how our periodic table would look. Let's just try to. Hanji, this is how it will look. So this will be the 6th and 7th, right? So there will be 32 elements. No, right? Yeah. So that is actually one of the reason because they wanted to make sure that the periodic table should not be like too big as well, because everyone will be studying it, right? It should be in the textbook and all that. So they wanted to make sure that it fits properly. Got it? Okay. Now coming to the valency, so this is something which you already have learned in the 9th grade. Let me remind you the chapter name as well, structure of atom. But valency is the combining capacity of an atom with other atoms. So how does it vary across the period? So valency, it first increases and then decreases. See, +1, +2, +3, +4, and then is -3, -2, -1, 0. So when the elements are gaining electrons, we use the negative charge. When they are losing electron, we use the positive charge. So 1, 2, 3, 4, 3, 2, 1, 0 it is. So valency across the period, it is increasing. First increases, then decreases. This is something I want all of you to note it down. And along the group, the valency remains same. So that's the first. And coming to the valence electron, so of course it increases across the period and remains same down the group. So we are already done with the two properties. And next is atomic size. So atomic size is basically the distance between the nucleus and the outermost shell in an isolated atom which is in the gaseous state. So how does it vary across the period or down the group? So the atomic size, it depends on two factors. Okay. So that is, one is the effective nuclear charge and the number of shells. So here what is happening, atomic size decreases from left to right. Why? Because the effective nuclear charge is increasing. Okay, so what is effective nuclear charge? Is the positive charge of an atom. So greater the positive charge, obviously that nucleus, because protons will be present in the nucleus, right? They can hold on to the electrons strongly and they just pull the electrons which are present in the valence shell closer to the nucleus. That will lead in the decrease of the atomic sizes of the elements across the period. So if you see across the period, it is decreasing because what is the reason also? It's very, very important because there is increase in the effective nuclear charge and the number of shells remains same. When you go down the group, so what happens here, of course, I'm just explaining it, so you will get the note. So you might be, sometimes you might be wondering, alright, this ma'am has already told. Of course, I'm like one step ahead than this PPT, but I'm sure you are getting my point, right? Do you want me to slow down? So when you go down the group, what happens is the atomic size increases, firstly because there is increase in the number of shells and effective nuclear charge is also increasing. But what is the problem is the number of shells dominates over the effective nuclear charge and there will be increase in the atomic size. So as you go down, the atomic size increases and across the period it decreases. The first property is done, and using atomic size you can explain all the other variations. So it is very, very important to understand why the atomic radius is decreasing, increasing across the period and down the group respectively. It is very, very important to know the reason. See, this is something which will help you, right, to when you visualize a chassis. This is the atomic size. The next property is metallic and non-metallic property. It is the C. Electropositive, metallic property, non-metallic and electronegative property characteristic is like almost same. So you have metals on the left side and non-metals on the right side. है ना? So obviously how does the metallic property vary? So metallic property decreases across the period. Non-metallic property increases because as you go from left to right, see, metals, metalloids, non-metals. So what is increasing? The non-metallic property is increasing. So metallic character decreases, non-metallic character increases across the period. So down the group it should be ulta. Metallic character increases, non-metallic property or the character decreases. Because so metallic property is how easily an atom can lose electron, and non-metallic character is the ease with which they can gain electrons. So because of the decrease in size, so they can easily gain electron, losing will be very difficult, and when you go down the group there will be increase in the size that should have been bigger than that. So that is the reason the atoms can lose electron easily, so their metallic character increases. So let me repeat it again. Metallic character decreases across the period, increases down the group. Non-metallic character increases across the period, decreases down the group. Okay, so here you will find the metalloids. Okay? The boron, silicon and arsenic and all that. So the borderline elements, that is, they are between the metals and non-metals, so they have the intermediate properties of both metals and non-metals, so that is the reason they are called as metalloids. Okay, and as the metals tend to form the cations, so they are electropositive in nature. So what happens to the electropositive nature across the period? It also decreases, and electropositive nature down the group it increases, same as the metallic character. Okay, metallic character and electropositive nature, it is same. So okay, across the period it decreases, down the group it increases. Non-metallic character and the electronegative in nature, see, electronegativity, electronegative in nature, please don't get confused. Okay, so non-metals, they accept electrons and they become anion, so they are electronegative in nature, so that also increases across the period and decreases down the group. Okay. So the opposite tendency of metallic character, so the ease with which an atom can donate or transfer or lose electron is what is metallic character, and non-metallic character is the ease with which the atoms can accept or gain electrons is what is non-metallic character. So as the effective nuclear charge acting on the valence electron, so the atomic size is decreasing, right, because of the increase in the effective nuclear charge. So it will be very difficult for an atom to lose electron because the nucleus will have that greater force on those electrons. So it will be very difficult for them to be, escape or get lost. It will be very, very difficult. Okay, so this we have already seen. Yep. So non-metallic character increases across the period, metallic character decreases across the period, metallic character increases down the group, non-metallic character decreases down the group. So next is electronegativity. So electronegative in nature and electronegativity. So what does electronegativity is? So the tendency of an atom to pull the shared pair of electron in that covalent bond towards itself is what is known as the electronegativity. For example, you have hydrogen here and chlorine or fluorine. So here the fluorine being more electronegative, again it depends on the size of the atom as well. So it will be more electronegative, so it just pushes the shared pair of electrons towards itself, and that is what is electronegativity. And non-metals are electronegative and metals are electropositive in nature, and these obviously when you go across the period, the electronegativity increases, and down the group the electronegativity decreases. Across the period, electronegativity increases, down the group it decreases. So this is the summary, and let me tell you about the electron affinity and ionization energy as well. So just because, just in case you want it. So ionization energy is the energy required to remove an electron from the outermost shell, from an isolated atom in its gaseous state. So energy. So obviously as the size decreases across the period, so you have to apply a lot of energy to remove an electron. So ionization energy increases across the period, decreases down the group. And electron affinity also, it increases across the period and decreases down the group. So there is the whole thing here in this one slide, whole summary of periodic trends. So please go through it, and if you are confused, of course you will get the notes as well. So as soon as the session ends, or within 2 hours, sometimes you will get it the next day. So please do check the description box. Maybe if you want to join the Telegram group where you will get the updates, so you can, the link is available in the description as well. So go through it. If you have any confusions, if you have any questions related to this chapter, ICSE, yeah, CBSE, so don't worry, for ICSE we have already done, right, periodic classification, yeah. So we will be coming up with more one-shot videos, and do let me know if you have any doubts in the comment section. So thank you so much for watching the session. So in today's session, we have completed the periodic classification of elements. That is it for today. And if you want to take up the pro subscription, the link is available in the description. And make sure to use the coupon code SURPRO for additional 20% discount. If you don't like discount, then okay. Okay, and subscribe to the channel, give me the thumbs up, and share this video with few of your friends, no, all of your friends. And yes, let me know in the comment section how was the video. Thank you so much, people. And see, less is more. If you attend more number of sessions, the lesser price you have to pay, and use the coupon code SURPRO. Thank you so much. Bye bye. Take care.